Welcome to the Theory of Computation. In this lecture, we will be studying about finite state machine. Okay, so let's get started. So finite state machine, it is also known as finite automata. And this finite automata is divided into two categories. The first one is the finite automata with output, and the second one is the finite automata without output. Finite automata with output has two categories, namely Murray machine and Mealy machine. And in finite automata without output, we have three categories, namely deterministic finite automata or DFA, non-deterministic finite automata or NFA, and epsilon non-deterministic or epsilon NFA. Alright, so in this lecture, we will be mainly focusing on studying about deterministic finite automata or DFA. Okay, so DFA stands for deterministic finite automata. Before we start in DFA, let us remember the two important properties of finite state machine that we should always remember, and that is finite state machine, it is the simplest model of computation, and also finite state machine has a very limited memory. So these are the two important points that we should always keep in mind before we study anything related to finite state machine. Okay, now we can start up with deterministic finite automata or DFA. Now to make the DFA clear, let us take a simple diagram that will make the structure of DFA clear to us. Structure of deterministic finite automata or DFA. So, first when you look at this diagram, you may feel confused what are these. We see here some circles labeled as A, B, C, D. We see some edges, some arrows pointing here and there, and then we see some numbers labelings like 11011, and what are all of these? Okay, so I will explain to you what this means so that the structure of this DFA becomes clear to us. So first of all, first thing that we need to know are states. These circles represented by A, B, C, and D, these circles are known as states. Okay, A, B, C, D are states. And then we see some edge. See, one edge goes from A to B, another goes from B to A, another edge is from A to C, another from C to A, and here we see one going from C to D and D to C, B to D, D to B. So what are these? These edges are actually the transitions. So what does this mean? These transitions means that supposedly the state A and this edge labeled with 1, this labeling of edges are called inputs. So what it means is that when I'm in state A, and if I get input 1, if the input 1 I get is 1, so my state goes from A to B. Alright, and in the same way, if I'm in the state A, and if I get input 0, then what happens? State A goes from A to C. Okay, and let's take some examples. Suppose I'm in state C and I get input 1. So where I go from C to D. And in D, if I get input 0, it goes from D to B. So that is how the transition occurs. So these labelings of the edges are our inputs and the circles are states. So it shows how the state transits from one state to another, getting certain inputs. Okay, that was about the state and inputs. Now we see there is something different about the state A and state D. In state A, we see an arrow that is coming from nowhere and pointing to A. So what is this? This means that A is the starting state or the initial state of this DFA. Whenever you see an arrow coming from nowhere pointing to a state, that shows that that is the initial state or the starting state. And if you look at state D, there is something different. Every other state has one circle. This state D has two circles. It has a double circle around it. And what does that mean? Whenever you see a double circle, it means that that is the final state or the terminating state. So this state D, represented by two circles, is the final state of this DFA. So now let's write down the formal definition of this DFA. So every DFA can be defined using 5 tuples, which are Q, sigma, Q naught, F, and delta. Every DFA can be defined using these 5 tuples. Let us see what are these tuples and what does it mean. First of all, we have Q. Q is the set of all states. The set of all states is known as Q. And what is sigma? Sigma is the inputs. The inputs are represented by sigma. And then the next one is the Q naught. What is Q naught? Q naught is the start state. The start state or the initial state. And then the next one is F. F is the set of final states. The set of final states is known as F. So here in this example, we have only one final state, but we could even have more than one final states. Alright, and the last one is delta. Delta is the transition function that maps from Q cross sigma to Q. Okay, I will be showing an example. Now let us try to write down what are the values for these 5 tuples for this example that we have been taken for our particular DFA. First of all, we have Q. So what is Q here? Q is the set of all states. So what is the set of all states? A, B, C, and D. This is our Q. A, B, C, and D. And what is our sigma? Sigma are the inputs. What are inputs? We have inputs here 0 and 1. Zeros and ones are the inputs that we use here. Okay, that is the sigma. And the next one is the Q naught. Q naught is the start state or initial state. So I already told you, whenever you see an arrow pointing to state, that is the start state, so that the start state here is A. Okay, so the next one is F. F is the set of final state. So what is the final state here? D. We have only one final state. Whenever you see a double circle, it represents as the final state. So I should put it in a curly bracket because it could be more than one, but in this example, it's only one. So the set of final state is D. And the last one is delta. Delta is the transition function from Q cross sigma to Q. Now to demonstrate this, let me take the table over here. I use this table to explain what is a delta. So for that, let me have this table where the top part will be my input 0, 1, and my state in this part is A, B, C, and D. Alright, now let's see what this means. So suppose I'm in state A and I get input 0, so what happens? When I'm in state A and I get input 0, it goes to state C. Right? A to C. I'm in state A. If I get input 0, I come to state C. Alright, and if I'm in state A and if I get input 1, what happens? State B. Now let's see come to save. In B, if I get input 0, where does it go? It goes to state D. And when I get input 1, where does it go? From B, it goes to A. Now, I'm in state C. Suppose I'm in state C. If I get input 0, where does it go? It goes to state A. And If I'm in state C and I get input 1, where does it go? It goes to state D. Alright, and if I'm in state D and I get input 0, where does it go? It goes to state B. And from state D, if I get input 1, it goes to state C. So, this is the transition function that it matched from to Q cross sigma to Q. So, this is how to write the transition function from DFA. So, this was the basic structure of the DFA. Thank you for watching.